I study a different kind of bees now. Welcome back. I want you to think back to your most recent design project. Did it follow an orderly, step-by-step checklist with readily available components and a predictable outcome? Much like designing and assembling a car, which is a complicated design. Or did it feel more like driving on the highway, with dozens of different types of vehicles involved, each moving in different directions, changing lanes at a whim, forming a complex, dynamic system that you tried to shape and understand, but couldn't quite predict the outcome? I suspect that your work as a designer feels more like riding that highway and less like building a car. And oddly enough, the traffic is increasing every day. This complex, rapidly changing, interconnected world demands designs that adjust, adapt, and maintain their intended function when things get exciting. And this is the essence of resilient design. Clues for how to navigate this highway are actually all around us. They're found in the workings of your fantastically complex nervous system, in the ants that are swarming in your kitchen, and the underground communication network of trees and tree roots that are beneath this building. Designing for and with dynamic, living systems is the big game to play today. And guess what? You're here playing it. But many of our human-made designs are not resilient and not up to the challenge. So where can we look for this kind of design inspiration? Life has been at this game for 3.8 billion years. 99% of the species that ever walked, crawled, or swam on the planet are now extinct because conditions on the Earth changed. This is not the 99% that we want to be a part of. The 1% of species that are alive today embody the designs that fit the conditions on Earth at this time in history. And these species have much to teach us. My search for these answers started with a microscope, and I was looking deep into life at an unseen level. I began my career as an infectious disease researcher, studying viral communication at the microscopic level. But then I scaled up to work in viral media and social marketing, exploring how information moves through human populations. In the lab, while I was gazing at bacteria, I discovered an immense hidden world of activity, communication, and resource exchange at levels that would make Twitter and Amazon's servers spin. I realized that our own living systems have much to teach us. Your body is a remarkably resilient system, and it's a great starting point for our journey today. So we're talking a lot about resilience today. What does it actually mean from an ecological lens? Resilience is often thought of as the ability to bounce back after some sort of disturbance to the prior state of being. But from a living systems view, resilience is actually more about designs that can continue performing their intended functions when the conditions change, and then that design can adjust or adapt to the new reality within a certain range of flexibility. It's about responding to the environment in real time and having more than one best solution available in case the first option is blocked or changed in some way. Resilient design looks less like a repetitive trampoline and more like a spider's web when an insect flies through it. As designers, we make choices, and it's important to understand the trade-offs when we're considering resilient design. In our business systems and in our organizations, we often optimize for efficient strategies at the expense of resiliency. Our current just-in-time delivery system that relies on centralized production and distribution is highly efficient at moving resources where they need to go in a system. But it can grind to a halt immediately when a snowstorm closes down the Chicago Midway Airport and your new rubber ball van from Staples gets stuck there for a week. Similarly, designing a stable system, like growing a monoculture crop to reliably feed people, is made possible by a strategy of reducing variation and reducing diversity so that the system can expand more predictably. But that design strategy for stability increases the vulnerability to a single plant pathogen, a change in soil conditions, or even a change in consumer tastes. People may decide they don't want to eat corn anymore. So resilient design focuses on strategies that emphasize multiple solutions, diversity, connectivity, learning, and actually encouraging redundant resources. And these design choices have their own costs. So there's trade-offs to be made in creating the world that we want. So how does this resilience game work? Well, here's where it gets fun. If we want to create a resilient design, it needs to fit the rules of the game. And there are rules. The designs that surround us in nature were created under a simple set of constraints. Use energy from sunlight, chemistry that's based on water, work with gravity to manage form and energy use, take advantage of cycles from light and dark to the pull of the tides, and always work with a dynamic system where you know that conditions will change from moment to moment. Within these simple parameters, nature has generated millions upon millions of design solutions that are continuing to adjust, adapt, and refine and experiment. From a rhinoceros beetle that can hold 850 times its weight on its back using its exoskeleton, to a monarch butterfly that is able to detect the scent of its partner from 5 miles away. You can be this creative too. The sky literally is the limit. So this is all very exciting, but where do we begin? How do we start to actually look at nature for understanding resilient design strategies? I want to offer you a metaphor. Imagine that you're in a kayak and you're navigating a river. You're carefully watching the patterns of eddies on the surface of the water, the swirls. And it's not because those are interesting, it's because those patterns reveal to you where the rocks are underneath the water that you can't see. And this is the magic of patterns. They reveal the relationship between important elements of the system just below the pattern level. So when we notice patterns, we often try to change things at the pattern level, like, why are there always dirty dishes in the sink at work? We can't really change it at that level. That gives us a clue to elements of that system that are in relationship to each other that we actually can change. So patterns are the clue to the underlying relationships of the system. These are some of the core patterns that we find in resilient systems out in nature. They are common, they're deep, we find them everywhere. And they offer us clues to new types of relationships that we can actually work into our designs to encourage a resilient system. So let's look at 3 of these. First, you can remix information. The birds do it, the bees do it, even human beings do it. Recombining information in a certain way is the driving force of life. From millions of bees collecting pollen and remixing the DNA of flowers, they're yielding much of the diverse types of food that we eat. Or to conversations at a party, or a hackathon, or a meetup that lead to new possibilities. Distributed communication, this information reshuffling and remixing is almost the urge of life. And it's essential to knowing where resources lie in a system so that a redundant or a resilient solution can be offered. Life also favors feedback. Thank you. Wow, 10 minutes goes by really fast. So feedback, redundancy, and using the unexpected when those black sheep show up, it's a sign that the resilient system is speaking to you. So there's a bigger game to play in design. You came equipped with the superhero set, and it's game on.